Okay, so Bismillahirrahmanirrahim. In the last class, if you remember, we have already seen that how the real images are formed for different position in case of concave mirror, right? And I told you that almost all the time we get a real image in concave mirror except just one case. What was that one case? That one case is if the image is placed, if you remember, we started from infinity, right? The image was at the object was at infinity, then it was outside center of curvature, it was at center of curvature, it was between center of curvature and principal focus, then we ended up at the object as principal focus. Okay, one more.
Assalamu alaikum, sir.
Walaikum assalam.
স্যার
Yes.
আপনি বলছিলেন আমাদের একটা ভিডিও দেখাবেন।
হ্যাঁ, ভিডিও দেখাবো। তার আগে এখানে একটু এক্সপ্লেইন করে নিই যে আমরা কি দেখতে যাচ্ছি। মেন্টালি একটু রেডি হও, তারপরে ভিডিওটা প্লে করবো ইনশাআল্লাহ। সমস্যা হচ্ছে ভিডিওটা আমি ডাউনলোড করতে পারিনি, তো ইউটিউব থেকে আমাকে প্লে করতে হবে। এখন জানি না আসলে কতটুকু ক্লিয়ারলি তোমরা দেখতে পারবা। আমি ডাউনলোড করার চেষ্টা করতেছিলাম এতক্ষণ, বাট এটা ডাউনলোড করতে পারিনি। বাট আমি এটার লিংক কিন্তু তোমাদের গ্রুপে দিয়ে দিছি, ওকে? তো ওখান থেকে তোমরা দেখে নিতে পারো। ওইটাতে এখন যেটা পড়াবো সেটাও আছে, আবার গতদিন যা ডিসকাস করছি ওগুলো সবগুলো খুব সুন্দরভাবে রে ডায়াগ্রাম দিয়ে দেখানো আছে। সো ওইটা দেখলে ইনশাআল্লাহ তোমাদের বেসিক আরো ক্লিয়ার হয়ে যাবে। Okay, so this is principal focus, and then we can say that at this point we will have the center of curvature. Okay, so the last position that we saw yesterday or the last class, the object was at principal focus. What if we go further? What if we go nearer to the mirror? Then the object will be between principal focus and the pole, right? Then what will happen? In this case only, the virtual image will be formed. How? Virtual image means the image will not be in front of the mirror. It will be behind the mirror, or we can say inside the mirror. Okay, how this is going to happen? To get the image, you know, I need two reflected rays, and two reflected rays will come from two incident ray. So one incident ray is as usual, okay, that is parallel to the principal axis, and after reflection it will pass through principal focus, which will be, I think, আমার মেজারমেন্ট আসলে এখানে অ্যাকুরেট হবে না, বিকজ আমি জাস্ট অ্যাজাম্পশনের উপর নিচ্ছি। ওকে, সো যাই হোক, তো it will pass through the principal focus. This is one reflected ray. I need another reflected ray, right? So another reflected ray, what I will do, I will take it along the center of curvature. That means along the radius. So along this line, if it is incidenting, then what will happen? We know that if any ray incidents along the radius of curvature, it will be reflected back along the same way. So it will be reflected back along the same way, passing through the center of curvature. So looking at these two reflected ray, do you see any hope? Do you see any hope of them meeting in some point in front of the mirror? They are moving further away from each other, right? So if I want them to meet, what I need to do?
I need to extend the principal axis.
Right, we need to extend the reflected rays backward. Okay, and
Yes.
whenever we extend the reflected ray backward, we show it with dotted line, and we can see that this is the point where they are meeting, right? So as this is a perpendicular object, we will draw a perpendicular from this line. Okay, so if O and Q, this is the object, then the image will be O prime Q prime. Okay, now I want you to tell me what is the nature, position, and size of the image. Okay, so at first we will talk about the position of the image. What is the position of the image?
Backside of outside.
Behind the mirror, right? Okay, behind the mirror, or we can say inside the mirror. Behind the mirror. What I can say about the size of the image?
Size is greater than the real.
Magnified.
Magnified.
Right? Magnified.
Sir, এটা greatly magnified হবে না নাকি only magnified?
Only magnified. Greatly magnified হবে যখন ইমেজ ইনফিনিটিতে ফর্ম হয়। ইনফিনিটির অবজেক্ট গুলো অনেক বড়, সান, মুন, ওগুলো। ওকে, তারপর হচ্ছে নেচার অফ দ্য ইমেজ।
sir, normal, same. Inverted
First
na.
of all, you have to tell me real or virtual.
Oh, virtual.
Virtual. We all agree on this, right? Virtual. And is it erect or inverted?
Erect.
Erect, because the arrow shows in the upward direction. Here also the arrow shows in the upward direction. Okay, till now what we got, the image we got is inverted, right? This is the object, but we get the image in this direction. If you go through the previous lectures, you will see. But now you can see that this is erect, right? Okay, so virtual and erect. And this is the only case in concave mirror when we get the virtual image. In all other cases that I have shown you till now, that gives us the real image, right? That is why, you know, this is different. And due to the difference, this is one of the most favorite question of the exam, those the people who make the question. Okay, we can say the teachers. Okay, so this, you know, whenever you know, creative comes from reflection of light chapter, this, you know, is very often or frequently seen in the question papers. Okay, so please practice this diagram at home. Without practicing this at home, it will be very hard for you to actually draw this on the exam paper. Let me warn you what is the difficulty that you are going to face if you don't you know, practice this at home. If you you know, whenever someone tries to draw it for the first time, you know what happens, you have a certain limitation of the page, right? Okay, so sometimes it happens they are extending this, but they are not meeting within the page, right? দেখা যায় যে পেজ হচ্ছে এতটুকু, okay, and the light rays are going like this. দেখো পেজের ভিতরে মিলে নেই, পেজের বাইরে গিয়ে মিলবে, তো পেজের বাইরে তো তুমি ড্র করতে পারবে না। Then what you have to do, you have to erase many things and then make it all right. So how to do it, এখানে অনেক ফ্যাক্টর আছে যেগুলো মানে কনসিডার করে তোমাকে এটা আনতে হবে। এই ফ্যাক্টরগুলা আমি তোমাকে বলে কখনো বুঝাইতে পারবো না। এটা যেটা করতে হবে, তোমার নিজে ড্র করে বুঝতে হবে যে ওকে, আমার বোধহয় এই জিনিসটা এইভাবে নেওয়া দরকার ছিল, ওই জিনিসটা ওইভাবে নেওয়া দরকার ছিল। এইভাবে করে করে যখন বুঝবা, তখন তুমি এটা পারফেক্টলি ড্র করতে পারবে পরীক্ষার হলে ইনশাআল্লাহ, অন দ্য ভেরি ফার্স্ট অ্যাটেম্প্ট। ওকে, বাট বাসায় এটা অনেকবার করে যেতে হবে, তাইলে পরীক্ষায় একবারেই হয়ে যাবে। আমি আবারও বলতেছি, পরীক্ষায় যদি এটা মিলাইতে যাও, you will not be able, এটা পরীক্ষার হলে অনেক টাইম নষ্ট করবে। সো প্লিজ প্র্যাকটিস দিস এট হোম। ওকে, নাও যেগুলো আসলে আমরা ডিসকাস করছি ঠিক সেম জিনিসগুলাই আসলে যে ভিডিওটা তোমাদেরকে দেখানোর কথা ছিল সেই ভিডিওটার মধ্যে আছে। তোমরা দেখো ভিডিওটা, আমি আসলে খুলেও রাখছি, বাট ভিডিওটা আসলে আমি এখন জানি না প্লে করলে তোমরা কতটুকু দেখবে। এই যে দেখো, এটার নাম হচ্ছে রে ডায়াগ্রামস 1 of 4 কনকেভ মিরর। সো এখানে আমি এখন প্লে করতেছি, তোমরা একটু দেখো যে মানে তোমরা কতটুকু শোনো। ঠিক আছে, যদি ক্লিয়ারলি বুঝতে পারো, দেখতে পারো, তাহলে ভিডিওটা আমরা রাখবো, আর নাইলে ভিডিওটা এখন প্লে করব না, তোমরা বাসায় দেখে নিবা, আমরা পরের টপিকে চলে যাব। ঠিক আছে,
সাউন্ড দিবেন না স্যার নাকি?
Use those ray diagrams to locate the image.
Oh,
Here's the general diagram we're going to
Perfect,
use.
sir.
We want to kind of make sure we know the important F.
মানে
And
smooth।
2F was twice as far away as F. You
Pause
should
করেন
be able
স্যার,
to
তারপর
say
বলতে
something
পারবো।
about the location of the image on the principal axis, the size of the image relative to the object, the orientation of the image, and the type of the image. Okay, so here's our first problem. This is the general diagram we're going to use again. Here is the object, here's the principal axis, here's the mirror, and you, your eye, and the object are on the same side as the mirror. If you think about how you use a mirror, usually looking at something, oftentimes it's your face. Okay, so here's the object, and we need to draw the ray diagram. Now, before we do that, I just want to remind you, whether it's a concave mirror, a convex lens, a concave lens, or a convex mirror, you should notice that for all four of those things, the ray diagrams are basically drawn the same way. So you don't have to memorize a bunch of different ways to draw the ray diagrams. You just have to memorize the 2 or 3 rules that we're going to use, and then you can apply those rules to all 4 of those optical devices. Okay, so for example,
I already taught you 3 rules, right? Using these 3 rules, we can actually draw any ray diagram, both for mirror and for lens. Inshallah, for lens, we are going to learn in refraction of light chapter. That is the next chapter, okay?
for the concave mirror, the first ray we draw, we're going to draw it from the tip of the object, and it always goes into the mirror parallel to the principal axis. So this light ray comes off the object, it goes into the mirror parallel to the principal axis, and it comes out through F. So it goes like that. So this one has to be parallel, and this ray, when it's reflected off of the mirror, must go through F. It's just not some random angle, this angle in here. It's drawn so that it goes through F. And you should have a nice straight edge and a nice sharp pen or pencil, preferably in case you make a mistake when you draw your ray diagrams. Okay, always use a straight edge. It's not a freehand sketch. All right, the next one goes into the mirror, and it goes into the mirror through F, and then it comes out parallel. So this one's the opposite. The first one we drew was parallel F. This one is F parallel.
There's something inside each and every one of us that compels us to know the unknown.
Parallel, and you'll notice the lines intersect, the rays intersect right there, and that is where the image appears. Okay, now based on that ray diagram, we can say about the image that when the object is beyond C, greater than C away from the mirror, the image will always be somewhere between C and 2F. The image will always be smaller than the object. When the object is greater than C away, the image will always be inverted, and it will always be a real image. It's an image that is created by converging light rays, and they converge right there at that point. Okay, so before we go on, let's just review this. We drew two rays. Parallel was the first one. F. I like to call the first one parallel F because it goes in parallel, comes out through F. Then the next one, the second one, goes in through F and then comes out parallel. So they're opposites of each other. Now we're going to do the exact same thing. Now we have moved the object so that it is right at C. So we're going to go parallel F, F, parallel, and you'll notice that the object appears the image appears right there. It's at the same place as the object right at.
Can you find the similarity what we studied in the last class and what is going on in the video?
Yes. Yes.
Same, right? See, outside the center of curvature, and the image is found between the center of curvature and the principal focus, and it is inverted, right? From the direction of the arrow, you can see that it is inverted. Okay, the object is pointing upward and the images are pointing downward. So definitely they are opposite. And when the object is kept at center of curvature, the image is also formed at the same point, but invertedly, right? Okay, inshallah, I will forward you some more videos which shows some practical experiments, okay, conducted, which will, clear it will clear your idea more and more, okay. If the school were open, I could have actually shown those experiment in person in our laboratory, okay. But now let us just, watch this video. Okay. So kindly continue, and if anybody have any doubt at any point, then you may unmute yourself and talk and let me know, okay?
At C. So when the object is at C, the image must also be at C, or will always be at C. It'll always be the same size. It'll always be inverted, and it's still a real image created by converging light rays. Okay? So those two were basically drawn the same way. The third one, we're going to do the same thing again. Now we have moved the object so it's between C and F. So I pick up my nice sharp pencil and my straight edge. I draw my first ray going in parallel, coming out through F. It must go through this point. The next one goes in through F, comes out parallel. So once again, it must go through this point. You have to draw it through this point. It's not just some random angle or some random ray. It's the one that goes through F. And there is the image. And you'll notice now that the object is between C and F, the image will always be greater than C away from the lens, away from the mirror. The image distance is greater than C. That's what DI stands for, image distance. The image will always be magnified. It's bigger than the object. The image will always be inverted, and it's still a real image. Okay? So you should notice For the first three, we drew them all exactly the same way. Parallel F, F, parallel. And the image appears where those light rays converge, those light rays cross. Okay, now this one's a little different. We're going to draw the first ray exactly the same. Parallel F. Now we can't really draw the F parallel because we're right at F. We have moved the object so it's right at the focal point. So what we're going to do is we're going to draw a second ray that comes in and strikes the mirror right at the principal axis, like that, and then it's going to reflect at an equal angle. So this angle, the angle of incidence and the angle of reflection, have to be the same. And you'll notice when we're right at F, these light rays do not converge. They're parallel. In order to get an image, as in the previous three examples, the light rays must converge. They must cross. Parallel rays don't cross. Therefore, when you're at the focal point, when the object is at the focal point, when DO equals F, there is no image ever at all because those light rays are parallel light rays. Okay, so we drew that one a little differently, but it's the same general idea. Okay, here's the last one. Now, finally, we're inside of F. The object is inside the focal point. And you're going to do the same thing with the first one.
This is what I discussed today,
parallel
okay?
F. Now, the second one, we're going to draw the same way. We're going to go to the principal axis, and it's going to reflect at the same angle so that the angle of incidence, this angle, and the angle of reflection, this angle, are exactly the same. And you'll notice these light rays don't converge. They're not parallel, but they actually diverge. Now, your eye is over here. It sees these light rays coming towards it. It notices that the light rays are traveling in a straight line. It doesn't know about any of these reflections off of the mirror, so it assumes they traveled in a straight line, and your brain, your eye, follows those light rays back. It's looking for the intersection of those light rays, and if you follow them back, you draw them nicely with your straight edge and your ruler, you'll notice that those light rays converge right there behind the mirror. Okay, so when you're inside the focal point, you'll notice now our image is behind the mirror, so it's located behind the mirror, and you'll notice that it's switched from being upside down, inverted, to being right side up, which we technically.
Azan diche, let's pause for a moment, okay? Acha, the question that has been asked by Fatima, that in the image on the board, why doesn't the second incident ray reflect as parallel to the principal axis? Very good question, okay? The second incident ray that is incidenting, along the radius of curvature, she is expecting that it should pass through, it should pass as parallel to the principal axis. But that is the case when actually the incident ray goes through the principal focus. See, if you remember, I already told you about this, that when the light ray is parallel to principal axis, it passes through the principal focus, and it will be the opposite. Let's see. Okay. So it will be the opposite. See, when the light ray incidents parallel to principal axis, then after reflecting, it will pass through the principal focus, and when it incidents through the principal focus, then it will pass parallel to the principal axis, right? But what will happen when the ray incidents along the center of curvature, not through the principal focus, along the center of curvature? That time it will be reflected back along the same way. This is rule number 3. 3 rules we discussed, right? So kindly go through those 3 rules. This is rule number 3. If any ray incidents along the radius of curvature, it will be reflected back along the same way, because every radius is actually perpendicular to the tangent drawn at that point. In general math, you should have already studied this. Okay. I don't think we need to see that video anymore. You already got the idea, right? If you want, you can complete watching the video later, no problem. I will take the attendance. Okay, some other people are there. Oh, today the attendance is very good, huh? What is the case? Okay. So we are done talking about the image formation in concave mirror. What about the convex mirror? For convex mirror, we will actually study only one case, okay? Because it is the same always, okay? Wherever you keep it, the image is going to be virtual, okay? There is no way you will get a real image in case of convex mirror. Now, convex mirror is more often seen in our daily life. Can you tell me one example where you have, all of you have seen for sure? Where you have seen? Can you tell me? Anybody? In the roads while traveling, you didn't see?
Sir, in the spoon.
Spoon, yeah, obviously that is there. But in our practical life, like, you know, আমার মার্কার নিয়ে গেছে, নিয়ে আসতো একটু। So in L-shaped road, okay, let me draw it on the board. Whenever there is an L-shaped road, okay, the car will come and, you know, pass like this, or the car might come from here and pass like this. At this point, a mirror is placed. Can you imagine? That mirror you have never touched, I guess, but looking at the mirror, you can feel it. It is a convex mirror. In the convex mirror, you can see from here, whenever you are coming from this side, you can see in the mirror if any other vehicle is coming from that side or not, okay?
Yes.
Which helps
Silver
to
color.
avoid the accident, right? You have seen, right?
Sir.
No, Papa, please, I need. After the class, I will give you, please. Okay. So what happens is always please, Papa, class. Okay, okay. Tumi to hall mein khelo. Sorry for the interruption. Okay. So this is a convex mirror, right? Convex mirror. How many minutes we have? Oh, we have enough time. So if this is the pole and this is the center of curvature, then through these 2 points, we can imagine a line which is known as principal focus, right? So, sorry, which is known as principal axis, C and P. And in between C and P, there will be a point which will be known as principal focus. And, oh, sorry, I forgot. The sphere is like this, right? So the center of curvature will be here, right? Not on this side, that is out of the sphere. And in between, at the middle point of center of curvature and pole, there will be focus, okay? So now we can keep any object at any point, okay? Now we want to know how the image is formed, okay? So at the first ray, we need 2 incident ray to get 2 reflected ray. Number 1, let us say I have this one, okay? So can you tell me how it is going to pass? It will be reflected, right? But how it will be reflected? It will be reflected in such a way that you will feel like that it is actually coming from the principal focus. It cannot pass through the principal focus now, right? Because it will be reflected back in this medium. So how it will be reflected back? It will be reflected back in such a way that you will feel like it is coming from the principal focus. If you remember, while we were discussing about the definition of principal focus, there we already saw this, if you remember, okay? Now, if you have forgotten, then you can revise that video again, okay? If anybody needs the link, then you can tell me, I will give you the link. Okay. Then another light ray that we will consider that is incidenting along the center of curvature. Along the center of curvature. And we know that if a light ray incidents along the center of curvature, that means along the radius of curvature, what is happening? It actually reflects back along the same way, right? whenever it is passing, just now we saw that if a light was passing through the center of curvature, it will be reflected by like along the same way. Here, if it is incidenting along the center of curvature, okay, or we can say in the direction of center of curvature, it will be reflected back along the same way. Now we have our two reflected ray, this one and this one. Will they meet anywhere in front of the mirror?
Yeah.
They will never meet. So in order them to meet, we have to extend them backward, and we can see that we get an intersecting point, right? This is the intersecting point. And as our object is a perpendicular object, we can draw a perpendicular from this point, and this will give us the image, okay? If the object is OQ, then here it will be O prime, Q prime. That means this O prime is the image of O, Q prime is Q prime is the image of the point Q, okay? So we will see the object inside the mirror, okay? Now I want you to tell me what is the position of the object, position of the image. Position of the image?
Behind the mirror.
Behind the mirror, very good. Okay, and what is the size of the image? Has the image become magnified or diminished or equal?
So magnified.
Object is here, and this is our image. The image has become magnified or diminished?
Diminished.
Diminished, because it has got smaller. So diminished. And what is the nature of the image? Is it real or virtual?
Virtual.
Virtual. Real. এগুলা এই রে গুলা কি সামনে কোথাও মিট করে? We have to extend them backward to meet. So how can they be real?
Who said real? I said virtual.
Somebody said real. Okay, no problem. We don't want to know who said, but whoever said, I just want him or her to learn that this is virtual. Why this is virtual? Because they are not meeting anywhere in future. We have to extend them backward to make them meet, right? So virtual, and it is erect or inverted?
Erect.
Erect. If anybody have any confusion that how can I understand whether it is erect or not, ask question now.
Yes, sir, I have. How?
So if the image is in this position, right? See, this is the head. Sorry, the object is in this position like this, you know, standing upward. The image is also standing in the upward position, right? Pointing upward. So it is erect, but sometimes we get images which are like this. See, it gets inverted, right? The object is like this, but the image is like this, inverted. That time we will say the image is inverted, but now it is erect. Erect মানে হচ্ছে সোজা, inverted মানে হচ্ছে উল্টা। মানে একটা জিনিস এরকম আছে, তুমি এটাকে ভিতরে এরকমই দেখবা, ছোট বা বড় যেটাই হোক সোজাসুজি দেখবা। মানে তুমি যদি মিররের সামনে দাঁড়াও, তোমার মাথা উপরে পা নিচে, ইমেজ যেটা তুমি মিররের ভিতরে দেখতেছো সেটাও যদি মাথা উপরে পা নিচে দেখায় তাইলে এটা ইরেক্ট মানে সোজা। বাট কনকেভ মিররের ক্ষেত্রে আমরা কি দেখি? কনকেভ মিররের সামনে তুমি যদি দাঁড়াও তাইলে দেখা যাবে ওখানে যে ইমেজটা ফর্ম হয় সেটা হচ্ছে উল্টা। তার মানে তোমার মাথা উপরে পা নিচে না, ইমেজ যেটা দেখা যাবে সেটা হচ্ছে উল্টা, তোমার মাথা নিচে পা উপরের দিকে দেখা যাবে। সো সেটা কি? ইনভার্টেড। ঠিক আছে, ক্লিয়ার? আন্ডারস্টুড?
Yes, sir. Yes,
Yes,
sir.
sir.
Okay, so we are almost done. I think we need one class more. Okay, we will talk about simple periscope magnification. That's it. Okay, two more topics left. Inshallah, we will discuss about them in the next class because today we don't have enough time. Okay, so then I will give you the PDF okay, from which you have to solve the creatives. Okay, so within the next week, if you solve the creative, then alhamdulillah 1 week before we have completed the portion for that is allotted for grade 9, right? Okay, so thank you very much. Anybody wants to ask any question before we end the class?
No, sir.
Okay, then see you on Wednesday inshallah. Assalamu alaikum wa rahmatullah wa barakatuh.